Geological disaster in progress. That yellowish geyser is a mix of oil and gas spewing from the ocean floor. The darker it gets, the more oil there is. A conservative estimate, 200,000 gallons of oil each day. After 21 days, at least 4 million gallons. This is the biggest of 2 leaks escaping from a broken pipe, part of the so-called riser that carried the drill 5,000 feet down.
I'm surprised to see a break that's pretty much wide open, and to me offers some possibilities for maybe sealing it.
What caused the leak? Today in Washington, we finally got an answer. This 5-story high device is the critical blowout preventer on the ocean floor, designed to cut off oil in an accident. BP's internal documents show it was broken.
We have learned from Cameron, the manufacturer of the blowout preventer, that the device had a leak in a crucial hydraulic system and a defectively configured ram.
BP and the manufacturer are blaming each other.
The ineffectiveness of the BOP to control the flow is not the root cause of the event.
BP is scrambling to stop the leak. Their latest plan, the top hat. It was lowered to the ocean floor overnight, designed to capture the escaping oil and siphon it to a ship on the surface.
As I said, we're doing everything we can.
It occurred to me that after the failure of the first containment box on May 8th due to clogging by methane ice crystals in the cofferdam, that another solution is needed. Now, I'm not going to go into the legal political ramifications of, to me, what is important right now is not pointing fingers, but immediate solutions to stop an ongoing environmental disaster. As of now, the BP engineers are attempting to thread a smaller pipe into the broken pipe encased in a rubber seal. If this or the next attempt, the so-called top hat containment vessel, fails, then I am going to propose a slightly more radical solution. Underwater concrete has been used since the Romans and works quite well. As follows are 2 possible solutions. This is possible if all other means of containing the blowout fails. First, the wellhead and the blowout preventer has to be sheared off as close to the seabed as possible. Then prefabricated modules or slabs of concrete will be lowered to the site covering the blowout. The concrete would have to be sufficient thickness to prevent the blowout from boring through due to the enormous pressures of escaping gas and crude oil. Several of these slabs can be used. Another thought is to use the problem as part of the solution, using the escaping petroleum as a lubricant to position the slabs. To make sure this blowout is further sealed, submarines can be converted to deliver more concrete, perhaps to envelop the slabs and create an artificial seabed. The cost will be enormous, in the billions of dollars. The cost, if we don't contain the blowout, could be a very sick Gulf of Mexico, with unforeseeable consequences to the seafood industry, tourism, further energy development, blowback from other nations, Mexico, Cuba, Central America, who will also have to deal with this environmental destruction. Note, I will upload further videos with technical data on this procedure as soon as possible. Thank you for looking, and let's hope for the best.